Hi everyone, welcome to Google Developer Space channel and thank you for joining us today. We are super excited to be hosting DataScience Singapore once again, and we have DataScience Indonesia for the first time together with us. Do make use of the live chat to ask your questions and let us know where you're tuning in from. Before we begin, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies, be it in person or online like today. Without further ado, I'll hand the stage over to the folks from DataScience Indonesia and DataScience Singapore to share more. Over to you, Alam.
Yeah, thank you, Gia. So, hello all. I'm Alam Shah. I'm from DataScience Indonesia, where DataScience Indonesia is the community of one of the biggest data science community in Indonesia, and we are not only talking about data talk and monthly, but we also have the free workshop. We also have the podcast. You can find us at Spotify and DataPods, and we also have the forum in our website, so you can follow us at there. So yeah, I think that's all from me from Data Science Indonesia.
Yeah. Hi everyone. So my name is Rizal. All right. So I'm with DataScience SG. We are very excited to have this collaboration with DataScience Indonesia. All right.
Yeah.
And for today, we're gonna for the next how much do we have left? About 55 minutes. All right.
Okay.
So we're gonna onboard three speakers who will talk more about the topic that's relevant for today, which is NLP. All right. Justin and Alam, I'll see you in a bit. All right. So let me get back to my hosting duties and bring on the speakers. Yeah. All right.
Yep.
See you guys in a bit.
Cool.
See you.
Right. See you.
All right. Hi. Welcome back. So just now there was just a quick transition. All right. So hi everyone. My name is Rizal. All right. I'll be the host for the rest of the session today. So just a little bit about myself. Right. I mean, aside from me helping out DataScience SG. All right, us as a community to cultivate a better, more well-knitted community here in Singapore, those interested in data science and whatnot. I'm also an AI engineer with AI Singapore, a national program that helps to boost national AI capabilities, all right, among many other things. And today we're incredibly stoked, okay, because we have not one, not two, but three, all right, people who are experienced in their own line of work, all right, people with much garnered experience in machine learning and anything regarding machine learning. But then today we'll be squeezing their brains, trying to find out their, what they think, their insights on NLP. All right. So first up, we have Aki, all right, who's the lead cloud engineer at Google. He focuses on optimization of machine learning models, right? He also deals with big data, terabytes of data. He'll have more to say about those things, all right. And then next, all right, we have Corey, all right, who is the founder of Camusai, all right. Just a little wave, Corey, all right. So Corey, he's also the founder of the Camus.ai, as well as which is a provider for on-premise NLP or NLU for ASEAN languages. And then finally, all right, we have Rizal, who is the founder of Polyglot Indonesia, and he's also a senior solution architect at Lan University, working with deep learning use cases pertaining to low resource languages. All right, so good to have you guys. All right, a very warm welcome. All right, to this session. Okay, how are you all doing?
Oh, having me.
Fantastic, thanks.
All right. So something that of course, something that's unfortunate with meetup groups, interest groups, things is that we are not able to, have a physical gathering with people But then, with a silver lining, I would say that comes with this circumstance that we are in right now is that we have contributed more efforts to basically bringing people from all over the world coming together, all right, for such events. So each of you, all right, myself, I'm in Singapore, and each of you are in different places, all right. So for Aki, you are in Sydney, right?
Yeah.
All right.
Correct.
Rizal, where are you at right now?
I'm in Denmark right now.
Okay. How about you, Corey? Where are you?
I'm usually in Singapore, but today in Sydney.
Okay. All right. See, we have people all over the world, from different parts of the world. So yeah, now that I've introduced each of the speakers, we would like to find out more about, what each of you do, in your line of work, be it pertaining to machine learning or whatever other domain expertise that you are, that you're focusing on. So perhaps I start with Aki, as per the order just now. Yeah. So what do
Hey
you?
everyone.
Yeah.
Yeah, so I'm Achilles. I actually lead a team of people based out of Australia, Sydney, and look after Google Cloud implementations with large customers in the region. So on a day-to-day basis, I manage a team across machine learning, big data, and infra. About particularly ML, we get engaged with customers who are like trying to build their own custom models or to optimize an open source model, and they have challenges around how do they deploy it on cloud and stuff. That's where my team gets in and helps them. So that's pretty much about myself. Back to you,
Okay.
Rajan.
All right, good to know. So you do have plenty of experience with multiple customers and multiple domains, and I think they so much need your your company's cloud capabilities. So now how about yourself, Corey? What can you tell me more about Camus.ai? What do you do?
Well, my background was I used to be at Rocket Internet and built some data science stuff in the region for Rocket companies. I spoke a few years ago at Data Science SG on the recommendation engines we did and the data warehousing and all that stuff. It kind of grew from that. The natural conclusion was to build my own AI company, which is Camus, and that's about understanding natural language and structuring it so that programs can use the content. That's basically it. And what's different about us is we try and do all languages, Thai, Tagalog, all the things that aren't really offered in the region. There's less people offering that, and doing it on premise. So that's actually on the customer's own network or their own hardware that's air-gapped. So I think we'll talk about that later anyway.
All right, cool. So yeah, I guess it complements well with Aki's line of job, where main concerns are with cloud, and then Corey does handle air-gapped deployments and whatnot. So all right, that will be cool, to find out each of the differing needs and challenges. All right, now of course now we have Rizal. All right, so yeah, you being the founder of Polyglot as well as senior solutions architect. So tell me about how come into this field.
Yeah, so basically my background, actually in electronics and then computer science, and then I've been in this field for I think 15, 20 years. And related to NLP was actually because I had passion in language, and I've been blessed to be able to learn multiple languages. And also, since my background in computer science, and then in my line of works, I tried to build search engine as services, where we use a lot of statistical method for getting the informations out of the index or out of the data text. And since 2 years ago, I went back to school and then working on specifically on the lower resources, because I think that's what we are lacking at the moment in the NLP space. So I'm working on the lower resource languages, currently focusing on the Southeast Asian languages, and as well as every 2 weeks, bi-weekly, we have this webinar series where we discuss NLP papers within Indonesian Association of Computational Linguists. So that's what I'm doing at the moment.
All right, great. So you do pertain some of the use cases that you tackle is pertaining to low resource languages. A similarity there with what Corey is doing with Camus.ai. All right, that's interesting. So Aki, so before before coming into before tackling machine learning use cases, before dealing with cloud, perhaps do you mind sharing with us on your basically your resume before or this field that you are currently tackling?
Yeah, so as far as NLP is concerned, I've been like bit on and off throughout my career. So it all started as a student in 2004, I will say, when I was still a student, and there was a national competition. It was a quite cool competition because they had given a list of words. Like if I remember correctly, it was like 500 words, and we had to compose letters out of it. And it was not any ordinary letter, but the output should have been something like a love letter. So that was my first forte and introduction to NLP. Quite a cool problem statement. You take a list of words and create a love letter out of it. As a student, we did some research and like we tried to build some models. Uh, During 2004 timeframe, this was like quite cutting edge. And if you guys know Indian Institute of Technology, IITs, we won the gold medal, me and my team. The idea was quite simple. It is about template-driven mechanism. Just generate your English language conformant templates and fill in the blanks with the given words. Okay, that was like the kind of cutting edge technology in 2004, right? Like for language processing.
No, but the application of basically to able to automate the writing of love letters, I think will still be relevant. Do share with us if the code is open source. I think a lot of the guys will be interested in it.
Sure, I will have to dig my hard disk. Okay.
Oh yes, please. All right, that will be much appreciated. All right.
Yeah. So just to continue, like beyond that, when I joined YouTube as a partner technology manager, I was responsible for YouTube's video analysis and helping partners onboard their videos to maximize the reach to audiences, right? So if you know YouTube as a platform, it's mostly related to video. But if you start looking into the comments and the video descriptions, there's actually wealth of information which can be derived from that. So that's where I started real world processing. This was in kind of 2016 when deep learning model were still not mainstream. And we were using topic modeling, LDA, those kind of stuff, which are very traditional. Treat it as an information retrieval problem, right? That was the mantra of the days. From then on, like for last 4 or 5 years, we have always gone more and more complex about the use cases of NLP. And today we are talking about BERT and GTP's models and how do we optimize them, train them in an economical way. So that's quite an interesting journey for me on this field.
All right. Okay. So there's some transition there. I mean, you have tackled multiple machine learning use cases, but I see the jump from computer vision to NLP there, right? So yeah, that's something I think a lot of practitioners such as myself we do jump in from domain to domain, so we don't necessarily stick in a field of machine learning. So thank you for detailing your your transition of interest. For you, Corey, how you just mentioned about you did give a talk with DataScience ISG some time back about recommendation systems. So now your AI startup is on NLP. Do you mind sharing with us, what about NLP, that may perhaps intrigue you such that you are making that move?
Sure, but first I want to see a benchmark of GPT-3 against Akhilesh's love letter model. See what comes out of it.
We can't even compare, right?
All right. All right, so I mean, it's kind of a similar story in the sense that an event pushed me to move to that particular area of machine learning. I think a lot of the techniques apply to a lot of fields, and we'll find a lot of people in the field will work on many things that are called different fields, but are actually just software engineering that happens to be stats learning. So in our case, it was a bank that wanted to do something, and they were blocked for several years on a single problem, which was to try and understand text from customers in the chatbots. And the key constraint was you can't ship any of the data out. So you can't use effectively all the mainstream NLU services or NLP services to understand what's going on in the chatbot. And the secondary constraint, the bank being in this region and being fairly large, I'm sure many of you have a card of it in your pocket at the moment, it was ASEAN languages. So again, at the time, and I think still today to some extent, very few people doing Thai, Tagalog, Bahasa Indonesia, Bahasa Melayu, all the things that are spoken here, which of course the customers are speaking. And it might be even, we've been asked about Hokkien for Singapore. So, it's not just the official languages. And effectively, yes, we had to kind of learn enough about the field to unblock the smart chatbot idea, and everyone wants one at the moment. I think, again, that's something we'll talk about later. And they liked it quite a bit, so I thought, okay, let's spin out the project, wrap a company around it, and offer it to everyone else. That's good.
All right, that's great. Yeah, we shall find out more about Camus, the specific challenges that Camus.ai has in terms of creating all these custom models for low resource languages. So for Rizal, all right. So you tackle low resource languages, all right. But what are the like prevalent problems that people might not realize when it comes to tackling low resource languages use cases? Because oftentimes people just straight away think, oh, I need to get more corpus, more data. So then they just, zoom ahead with collecting data. But, perhaps there are some things that people might miss out when, in the rush for collecting more data. So what do you think are some of these things?
Yeah, I think it's related to the data that we have. It's not like we lack of data. It's just like the data is quote dirty. It's not clean. Means like it's not either labeled or it's not clean enough. Like for instance, we have this in Bahasa Indonesia we have open subtitle corpus where we have around 10 million sentences. But if you dig down to the data itself, and then you try to clean it up. I tried to clean up the open subtitle, and then I got around 6 million out of 10 million. And because of the data itself is dirty, means that it has a format that is not Indonesian or so on and so forth. And also a lot of NLP tasks as well. So in low resource, there is two types, which is the low resource language in terms of the data availability, and then the data availability to the NLP task. So for instance, if we want to do like sentiment analysis on Bahasa Indonesia, we have a lot of data from Twitter. But if we want to do like machine translation tasks, we don't have enough because we need to have like parallel data set or parallel corpora to do that. So Bahasa Indonesia in particular is categorized as one of the papers says a rising news star. It means that we have a lot of, in Bahasa Indonesia, has a lot of monolingual corpus or monolingual data. But then for machine learning in particular, we don't have a lot of data compared to the other Western languages. So that's one thing that we need to do. Like if we want to collect a corpus, we need to know what kind of NLP tasks that we want to do, and that we try to get the data as much as possible in that specific task, for that specific task.
So I think that's a very striking insight, where actually just having huge volume of data isn't enough, but you need to have the relevant data, enough volume of it for the specific use case. Because even for NLP, there is like you said, there's for example like sentiment analysis, text generation or translation and whatnot. So okay, that's a very good point. And what more, I think in Indonesia, it's such a interesting. I mean, for some people, they will be struck with fear, but some people will be struck with excitement, because in Indonesia you have one of the largest number of languages and dialects, right?
Yes, that's another thing that is pretty challenging for Southeast Asian languages, that we are using a lot of code mixings in our sentences. So mixing 2 or more languages in one sentence. That's particularly challenging for doing NLP in Southeast Asian language. Like for instance, in Singapore, you probably mix maybe Malay, English, Hokkien, something like that in one sentence, right? And then that's also challenging. I did publish once this year related to how to deal with code mixings as well. And that in Indonesia itself, since we have a lot of languages, so it's kind of like double-edged sword. First, it has a good opportunity. The other hand, since we kind of like trilingual, we try to use those 3 languages in one sentences or in one document, which is not good for NLP, which is because most of the NLP tasks that we have assume that the data is in one language.
Certainly us here at Singapore, even with my organization, we have a lot of we get approached by government agencies saying that, hey, we want models that's able to cater to cross translational use cases, because, like, for example, when people call in for police, what do you call it, when they call in for police, the thing is that they will often switch, context switch very fast. And when we are trying to build models to handle this kind of transcribing use cases, the blocker is always finding enough data that's able to handle that context switching.
That's tricky. That's why it's an interesting space, and it's not a lot of people actually on that. And I think in the future, people start to do research outside of just looking for state of the art.
Oh yeah, I think people, when all these big companies, tech companies, they announce, all their open source language models like BERT, GPT, and then they will soon face the stark reality that it won't be applicable to, their own use case. So so Corey, how about yourself? How much of whatever Rizal has shared in terms of tackling low resource languages is very much relevant for your work, in Camus.ai, especially when you, the clients that you face, basically they will always have, their own set of challenges and blockers. So how much of it are relevant with whatever Rizal has mentioned?
Yes, I think you mentioned the key one. I mean, the data is dirty. Every speaker has their own way of spelling and speaking, and the dialects. The dialects were actually another constraint that stopped a Bahasa deployment for many people in this region. I've heard over 100, I've heard 60, I don't know how many there are, but the point is you have to cope with the different ways in which Indonesians on their island or their corner of Jakarta speak, and that's very hard to use generalized models for that. And
if I can add a bit, like there is around 13 to 15 variation of the word "I" in Indonesian speaking. So that's problematic because depending on the region or depending who write the sentence, there is around 13 to 15 variation of the pronoun.
So in our case, our solution was to build something that works with very small amounts of training data, so that it could rapidly learn and adapt to whatever customer base the client had, as opposed to trying to going for the GPT-3 approach of a billion variables and data sets that cost 100 million. So and it's really been the only way we could solve the problem, because we now have 100 million. So in terms of difficulties, I would say exactly as Rizal said, it's very hard to get enough training data in those rarer languages. You can't get quantity and you can't get diversity to get good results. And the second thing that's a bit more of a process issue, it's very hard to get an instinctive understanding of languages that you don't speak. The feedback loop is a lot longer than when you develop for English, because you have to involve native speakers, and then you have to involve multiple ones, and you have to talk to them, wait for them to come back to you, try and think about what they're saying. Of course, if you're a linguistics expert, it helps. So how do we solve that? Well, we use fast text because we get 150 languages, and Facebook did a good job covering a sufficient amount of the landscape. It's not going to beat benchmarks, but it's a good start. There's a lot of stuff piled on it, but that's the start, and also it means we have to spend a fortune training the word embedding at the start. And it allows us to generalize and recognize things we didn't expect. But we still don't really know exactly how we arrive at a model with decent results. We're still kind of iterating. So if there's a new dialect, a new client, some new intents that we have to recognize, then we kind of iterate with training data until it works. And at the moment, about 5 training sentences is enough for an intent. So to get a fairly good percentage of new sentences recognized. And this is, we recognize we can't predict everything, so we focus on well-defined tasks always. We try not, you can just spin up an instance for your new task, and then it's very easy to evolve on the simple task. It's kind of the Kalashnikov approach instead of trying to build cruise missiles. And the only guarantee we ask of a pipeline is that it should work with anything that looks like what it knows. So we try and make as large a zone as possible around the training data. So to give you an example, if you train find cat, it will recognize Phyllis because that's the Latin for cat, because some people have used it, maybe it's the Wikipedia corpus. And the real story behind that is actually around developing the profanity filter, so I can't really relate.
Yeah.
It was very interesting trying to build a reliable and robust profanity filter. So we've looked into more evolved language models, and we tried many classifiers that are so-called cutting edge, but a lot of the time it doesn't work. So we kind of fall back to the simpler stuff that's more robust.
All right. Okay. So yeah, both of you mentioned, one of the challenges, of course, it's in being able to handle dirty data, and that's it's an issue that's increasingly prevalent once the volume gets larger and larger. So Aki, yourself, you handle tera, perhaps even petabytes of data. So this comes the concept of scalability comes into place, and and just to add on top of it, deep learning in general, it's very resource heavy. So what are the common challenges that you face or your team face when it comes to optimization of training, deploying NLP models, or even basically before even training, the problem of optimizing that data preprocessing aspect? Oh, Aki, we can't hear you, Aki. I'm not sure if.
Sorry, is that okay?
Yeah, we can hear you now.
Yeah, mic gets muted. Yeah. So basically, everything which Korean results said is valid, and even at a scale, if you look at BERT example, there are multilingual models built over it, but then based upon the language, the accuracy decreases drastically. Even for the top 5 languages, which is from English to Arabic, if you look into the published benchmarks, the accuracy varies from 80% to 50%. Same model, just that we don't have enough data for certain languages, right? So beyond the data problem, we also have the cost problem, right? Because even with cloud, the way you travel, the way you train your models, GPT-3, for example, will take years and years. And if you start training on a V100 model of GPU, right, you need a data center. You don't need one cloud, or you don't need hundreds of GPUs just to train one model, right? The published numbers are like something around 4.6 million per time GPT-3 is modeled, right? So those are the kind of costing which we are looking at. It's massive. It's not easy to build one model for like for every language which you know, right? But then beyond that, even things like which Corey said, that building multiple models. So how many models can you build, right? If you look at the number of languages in the world, there will be probably around 5 to 6,000 official languages. Massive number, right? So you always have to have a closed domain, and you have to filter down your limits on what you can do. Then there are things like when you start using this kind of automated tools, right? It becomes a tooling problem. Now, can you deploy 10 models and try to make sense of all of them, or one or two is enough? So those kind of issues come into play. And then you have to be always on a continuous feedback loop, right? If the success of models, particularly in the machine learning world, is actually changes the behavior of the customer as well. So you'll have to be aware of those facts, that if you don't train your model quite frequently enough, you will see the customer behavior is changing. For example, in chatbot, if you have built a good chatbot, right, customers will come to you, interact with you, but then the moment they figure out they write handover to an agent, the first thing they will do is come and start writing handover to an agent, right? That's the way people behave generally. So those are kind of like patterns we'll have to actively look out for. These are the common challenges I can think about in the top of the mind.
Yeah. So, when it comes to when I'm confronted with the concept of optimization, or having to train my model faster, like you, I don't think about data centers. You mentioned data center. That's a resource that you do have, but for most of us practitioners, perhaps what are some low-lying fruits that we can tap onto when it comes to optimization? Like, for example, like I think for one, when I try to build, a model, a computer vision model recently, I want to train it faster, and therefore I resort to something like automatic mixed precision training, and that's the kind of thing that I can access to, because trying to leverage on more GPUs is not really an option most of the time. But yeah, what do you think are some of the low-lying fruits that we can tap onto for optimization?
Yeah, so I'm great fan of Corey's approach, that you don't solve the Scud missile problem on the day one. Identify your domain, identify your problem statement, and that will give you easier start, right? And even don't be afraid of running your analytics and using APIs which are pre-built. For example, if you start with GPT-3 kind of models, they have reached their theoretical limits, right? In the paper itself, they have described adding more parameters is not going to necessarily help beyond this point. So now the question becomes, how can we build models which are more specific, and more generalized at the same time, right? And when you are selecting your tools, for example, TensorFlow, so the things like which you can do, use your mixed precision modeling as well as distributed training. Unfortunately, most of the common models which are available in open source are not distribution ready, which means if you take the model and start running it on GPU, you will soon realize they are only consuming one CPU, even if your one GPU, even if your cluster has 7 or 8 GPUs in there. So look for those kind of patterns where you can actually parallelize your training, so you can reduce your training time, right? And also the corpus, right? Don't start with Wikipedia data. That's overkill for most of the problems, right? If you are having a chatbot, you will end up a very context heavy, very domain oriented problem. So start with a corpus of data which you have. Don't go for the biggest model available. So those are some of the hints which I can give.
All right, good to know. Yeah, thank you for the reminder to not just go for the biggest and most flashy models out there. Yeah, so now, okay, I think I want to transit for a while out of like the whole talk about models, big models, model training and whatnot. So for Rizal, you're a solution architect yourself, where you develop and implement workflow infrastructures, and and this can pertain to DevOps, reproducibility and whatnot. So, but what do you think are some of the what do you call it, when it comes to tackling NLP challenges, use cases, what are some general toolings that you think would be useful in producing a more streamlined workflow?
So basically, my approach is I'm pretty agnostic on the tooling itself. Like, depends on your data as well. You can use, like, for instance, Spark, or maybe in AWS you have like a tooling, or in Azure or in Google as well. Right? If you are, I'm always like tell my friends, if you want to start doing this machine learning training, just use Google Colabs, because put your data in Google Drive and then get the data to Google Colabs, and basically you don't have to invest in anything, right? And then you can run on GPU, you can run on a GPU. But in the production level environments, it either, like, depending on the organization, some organizations cannot have the data outside of the organization, and some of the organization can. If you can, then you can use these tools that are available from any data or any cloud providers like Google, Microsoft, or AWS. But then if you cannot, like my university, where we need to have all of our data inside our own data centers, then we pay or we use open sources software. And then if we use open source software, there's a lot of open source software. Like, for instance, in information retrieval or search engine, we have Solar that has good tooling for tokenizing sentences, language identification, and so on and so forth. And also for machine translation, we have Moses for phrase-based statistical machine translation that is available, that is easy to use with good documentation. And as well, if you want to build your own or training your own machine translation system from scratch, you can have like Python, or you can have, well, there's different things, like you can have SoftEye, you can have a Nematos, you can have Marian plus NMT. Each tools has their own advantages and disadvantages. So I cannot say which one is the best. Like, for instance, if you want to try to code machine learning, you can have PyTorch, you can have TensorFlow, or you can just build vanilla Python with NumPy, for instance. But or you can use even Keras on top of TensorFlow. Different tools or different framework has their own advantages. So I guess we should go back to what is your purpose and what is your needs on, and what is your budget on that. And because of that, then you can search of different kind of tooling on the particular cases that you have.
All right, yeah. Well, that's a mouthful in terms of the number of technologies that you just introduced. Hopefully, for those who are tuning in, I hope you have made a list of whatever tools that he's mentioned. All right. I think he's mentioned some of the tools that he has mentioned are tools that has existed. For example, like Solar. I think a lot of all these relatively older tools, are something that people don't realize that they are still relevant, even though they might not be as fresh or flashy. I think people should not discriminate tools as such. After all, there's no one size fits all when it comes to tooling. Then Rizal just now mentioned about one of the considerations when coming up with a workflow, it's the privacy concerns. And so for Corey, for yourself, you do place an emphasis, or rather, one of the offerings for your startup is deployment on air-gapped infrastructure. So and this also is incredibly relevant nowadays because due to the increasing interest in privacy preserving systems. So with all your experience working on Camus.ai, how relevant has this technology as like federated learning or differential privacy is very much relevant for your line of work? How useful are these in the immediate time?
So I think it's important not to focus just on the technological problem, because technological problems are always solved in the end. At some point, the model is too hard to use, and one day it becomes easy to use, and it's easy to use forever. And no one ever thinks about it again. I mean, do you build your own Linux from source? Have you read the source code like Stallman? No, you just install and run with it. So from that point of view, linking back from the point that Rizal was making, tooling is very important. We have a GUI to allow managers to manage the whole thing and so on. So, building that tooling that makes it easy. And I would approach the privacy problem from the same point of view. You have to take a step back from things like thinking about differential privacy algorithms and proving, that a set number of queries is going to identify a user in your healthcare data set or whatever. That's not how you think about it. You have to realize that a bank, or in fact, many, if I want to be quite cynical about it, many organizations are like a black hole. There's an event horizon and you get past it and nothing comes back out. So the main blocker is clients don't want to share stuff. They don't want to share stuff, in part because the CIO's career will be at stake and possibly, criminal charges in certain industries. And they don't want to because it's a lot of work. And it's a lot of work with zero payoff. It's like security, right? No one ever pats you on the back for not being hacked. And if you're Uber or if you're, a data broker and you leak 2 billion customers, what was the national security numbers in the US as well? These guys just get a job afterwards. They have no consequences. Like security and similarly, there's no helping your data science provider to get better is not something that's going to advance your career. So it's very, very hard to get data out, and that's really going to be the blocker. Not whether people understand differential privacy. It's going to be about whether they want to be bothered to implement it and put in the money and the time. So you have to assume that once you launch your thing, you're never going to talk to it again. And so you have to make it user-friendly for their teams. They have to be able to manage it by themselves, and you have to assume non-technical users. It's not an assumption that the developers will be incompetent. A lot of the time, they're very competent developers, but the developers don't have the time. The product managers don't have the time. No one wants to pay attention to it. You have to make it as easy as possible if you want the product to keep improving. And it is possible. If you can improve your model, they can improve your model if you give them the tools to do it.
Well, thanks for the start realization that, not just tooling that's, that comes to consideration when implementing such systems, but bureaucracy and politics, have a huge part in it. Okay, so I think we do have questions from the ground. We do have a lot of comments over here. Let's see. So for those slow, so we have a question over here by Tony Tong. Okay, for those low resource languages, is using machine translation models effective in increasing performance? Example, modern train in English but tune in a dialect, since the embeddings are numbers anyway. Yeah. So anybody wants to, perhaps tackle this?
Yeah. Maybe I can try to answer it. So yes, this is basically using pre-trained in another language. So in machine translation, there is a technique called pivot model. Pivot model means that if, for instance, you want to translate English to Catalan, and then you don't have enough Catalan to English language pair as in parallel corpora, then you can use pivot technique where you first try to have model built in English to Spanish, and then try to fine-tune the model that has been trained in English to Spanish to Catalan. That's a possibility to do that, and that's actually has been proven to increase the blue score for that. So that's one way to do it. To train in low resource languages. Another thing is you can use transfer learning, meaning that you are training on one particular NLP task on, for instance, okay, in Bahasa Indonesia, for instance, we don't have enough parallel corpora for machine translation, but we do have a lot in another NLP task. So we can use the model that has been trained in another NLP task and transfer the model to the particular task, which is machine translation. That's two models that we can use. Another thing is that we can do is just to increase the size of the corpora by doing data augmentation by using back translation or doing the data synthesis on the sentences itself.
Okay. All right, Tony, I hope.
I would just like to add also certain things around the specific question, which is, because the embeddings are numbers, can we reuse across languages? The answer is actually no, because these embeddings are not random numbers and assignments to a particular word, but they're derived from the context and actually represent the syntax of the sentences from which they are trained. So depending on the language, if your question is language is very tightly related to a dialect, for example, American English versus British English, maybe this can give you a kind of good result. But when you try to use the same trained model and try to fine tune it between, say, English and Arabic, you will see the languages are very, very different and the structures are very, very different. So in fact, you may not even be able to use those embeddings. So it actually depends on your use case and the language pair. If it is just about dialect, using the base language and fine tuning may be a viable option.
All right.
Yes, I think that's what has been mentioned is correct. Like you have to see how close is the language itself. Like Catalan and Spanish is really close, like dialect, but like Arabic and Russian, for instance, is really far.
Yeah, precisely. Yeah.
All right, thank you for the insights. Then we have another question next from Tracy Longwin. I think this I would like to throw to Corey, all right, because I think this person is trying to get insights on how to manage a team of data science. I think, and of course, your insights will be very much valuable in with your experience in Camus.ai, in handling a team and bureaucracy and customers and whatnot. So, yeah, what advice would you have for Tracy?
Well, that's a difficult one. Selling to corporates specifically is a sales job. Your organization becomes a sales organization. So in our case, we go through partners in order not to take that on. Support is very expensive as well in terms of time and also in terms of the morale of your developers, because nobody enjoys going to the client site and having to talk to a lot of people who don't really understand your product, trying to figure out. But it's very important because that's probably the only data you're going to get out. Someone is going in there into these networks that are separate. Your email doesn't work anymore when you're in the building. Your phone doesn't connect. But finally, out of the heads of people, you're getting a very, very reduced transformation of what's actually happened in production that you can feed back to the engineering process. And so, ironically, our company exists because we're replacing a service that, despite being well-funded and American and having many customers in the financial industry, was not doing this and did not understand the importance of getting information from the customer, listening to the customer, mostly because once they won the contract, they knew that inertia would keep them there for 4 or 5 years, and it was a very lucrative contract. And why waste money on developer salaries when you can just keep collecting? And so we don't make that mistake. We spend a lot of time with the customer just listening in their own words to what frustrations they're finding using the service. And that has paid off enormously, because sometimes you get what seems to be the smallest comment. Maybe someone has spotted syntax that doesn't work, and you're like, well, okay, I'm going to change the rule in my spell check. And then you end up rewriting the entire architecture of the model because it's highlighted some major bugs. And this communication often doesn't happen because the personality of a developer is almost orthogonal to that of someone with exceptional sales skills or the ability to listen to the customer. So yes, less technical answer, but you did say manage a team.
Okay, all right. Yeah. How about Aki or Rizal? Do you have any inputs for basically managing a team, or how? I think just now there was a mention from one of you about the concern of explainability of models, And I think something that a lot of even practitioners who have few years of experience, they tend to skim over it and just straight away deliver the results without taking into heavy consideration the client's concern. Yeah. So
Rizal, would you like to go ahead?
okay.
Yeah,
No.
I mean, the terms of explainability of the model, or the model is actually black boxes, also a hot topic in the academic communities, that we are doing. Some of the model are not explainable, and then a lot of research or a lot of interest starting to go to that area, which is doing probing of, like for instance, transfer learning. What is actually transfer from one model to the other model? This papers, or this kind of paper, has been published more and more the last 2 years. So I guess a lot of people trying to do that at the moment. But yeah, explainability is like hot topic even in the academics communities. So some of the people still need to know like why this is happening. Right?
Yeah.
I would, go ahead.
Sorry, I was just trying to add that, in fact, that is a very good question in terms of explainability being a requirement in certain industries, for example, insurance. So whenever NLP comes into play, and if you are parsing documents and legal documents, you have to also propose why it didn't work or work out. So many a times we have ended up building traditional models, just like taking a cosine distance, and finding out and trying to explain that this document is more similar to the other similar document, right? Which actually is accepted by customer, because even if you go with a fancier model which can classify but can't give the description of why those classifications were made, it's a problem. It's a genuine real world problem.
I just wanted to add, if you want to read research into explainability, the MIRI, the Machine Intelligence Research Institute, is doing a lot of really cool stuff, looking into algorithms, models for making AI less black box. But in our experience so far, nothing both works well for NLP and is explainable. So, we look at stats approaches, we look at reduced dimensionality, visualize, that kind of thing, just like any other data science task, really. And then what I want to add as well is, from a PM or sales perspective, a lot of buyers don't care about how it works. I mean, part of the sales process is realizing this. Part of putting stuff into production and keeping it in production is realizing that if you give someone a solution to that problem and they pay, they don't ask too many questions, they can move on to the next problem. And so there's very little incentive there's very little pull to actually make the models more explainable. And that's actually the big draw for the Jan LeCun approach, where you try and lose structure and work only on unstructured data as much as you can, the GPT-3 style advances. The approach is, the appeal is commercial as well as it is human. So it's really up to you as a developer to try and understand your models. Ironically, from our point of view, understanding the pipeline, understanding the process gives us a lot of robustness as well. So, looking outside the model, you can get a lot of explainability as well.
Incredibly, that's very relevant. With my experience also, I think a lot of people, I think especially for starters, they get excited about the flashy models and not realizing that sometimes, even just your basic multilinear regression problems might work, and what more is that such algorithms which are more conventional are not, resource heavy, and therefore they can even use their own machine to get started, because they always think about neural networks, deep learning. Yeah. So all right, thank you for that reminder. Let's see if we do have a question. Let's see. Okay, this one I guess. Okay, by Andreas. All right. Is there any drawbacks to using pre-trained model transfer learning to solve low resource language problem? I think some of you might have addressed this just now, but then perhaps I think we can further detail into this.
From my experience, like working on this low resource language, I don't see any drawbacks in terms of using pre-trained language model. It's just like the requirement to do this is you need to know what kind of model you need to use to actually doing the transfer learning. The parent model is important, and then usually the decision to choose which parent model that you are going to use to do transfer learning is much more important in solving the low resource language problem. And also I want to add, like during the model itself, use maybe using the complex model is not good, and then it's better to use less complex model. Like for instance, I did sentiment analysis on the Twitter, and then I tried multiple models from LSTM with attention mechanism, by LCM transform, and so on and so forth. And turns out the best result came from the model called deep averaging network, which essentially just averaging the factor that you get from word embedding for each word, and then divided by the number of the words inside, the number of the words in the sentence, and then you feed it in the multi-layer perceptron, and then that's basically the best result that I get for doing sentiment analysis. So, and that training time is a lot, like 2 order of magnitude than actually doing LSTM training. So that's one thing. If you have like low resource language problem, maybe try to narrow down to the domain that you want to do, like maybe legal domain, or maybe specifically translating a contracts, or doing like a contract classification, and then use and choose the parent model wisely.
Right. So I would also like to add that there are a couple of questions on the same topic, almost the same topic of fine-tuning pre-trained models. So just to clarify, transfer learning is a great tool, but it has its own challenges. It's not a holy grail. You can take a model and start believing that it will work for all the languages or many languages. So one of the drawbacks is very apparent if you read all the published papers around this topic. They do present transfer learning as a last resort, where they use the trained model to optimize where the syntaxes of the basic languages were same, right? But moment you start using across multiple domains, you will see the accuracy going down, even if you're using transfer learning. So just be careful about the domain, and as a result said, try to optimize and try to be a solving a closed domain problem, which will give much better results. But if you are trying to build any generic open-ended language model, you will see the drawbacks straight away in terms of losing accuracy.
I agree. Like there is there is almost no way in a language sense that you can build a generic problem. Even like GPT-3 is GPT-3 is trained on of the data before 2019. So if you ask about COVID-19, it won't recognize anything.
Yeah.
So on that subject, again, I have to take the general voice here. It's like using a popular open source project. So it's not bespoke to your project, but you get something that's been battle tested, that's been maintained by others. You know, the wrinkles have been ironed out. So that's very appealing. You just need to be aware of what's in it and whether it's applicable to your problem. So in terms of pre-processing text, you can use synonyms. You couple them with strict matching, then you have a low CPU, very fast name entity recognition. You also have to, you know, be aware of the structure of the sentence to match not just the spelling, you know, linguistic criteria. But it's very low CPU. You can actually bypass retraining the model that way. That's the secret to our, especially equity trading products. On spelling, it's a bit like the Indonesian dialects. One man's spelling mistake is another's perfect spelling. You know, we're not the Académie Française. We're not trying to define the language here. You know, you can define the language. You can be very correct and very not sold. You know, the customer doesn't pick your product. It doesn't work. So we let the customers pick the spelling.
Yes. Just to add a bit as well, like particular specifically for machine translations, if your data or your parallel corpus is under 80,000 parallel sentence, it's better to use statistical machine translation, not any neural machine translation model. And then even lower, maybe rule-based machine translation is even better if you only have like 5,000 or 4,000 parallel sentence.
All right. Yeah. So yeah, I think we have gotten most of the questions, or the general ideas that are being presented by the audience who have tuned in. Well, we do not have any more time to to address further questions from the audience. So we are coming to the end of our session. All right, for today. So I would like to bring back Alam. Hi, Alam.
Hi, hello.
Hey, Alam. Yeah. So
Yes.
we are very grateful for the three panel speakers over here. All right, we very much appreciate the time that you've put into this event. Yeah.
Yeah,
And,
thank you so much.
Yeah,
also, thank you so much for Cory, Aradi, and Aki. Thank you so much for your time.
Thanks for hosting.
Pleasure.
Thanks for hosting. It was my pleasure to talk to you guys, and thanks for everyone for your great comments and sending me LinkedIn invites. So keep sending those. I always love to get in touch with new people. Hopefully, we'll get to discuss, and when I'm in Indonesia or Singapore, we can meet as well. So, yeah.
Cool.
So, yeah. Thank you a lot for the invites, and thank you for listening. And I hope we can have we could discuss some of the concerns that you have, the audience, and then hopefully we can have another discussions. And thank you for the LinkedIn invites. I've been overwhelmed with the invites, so this is actually one of the day when I get the most LinkedIn invites. So just keep sending those, and then if we want to, we can discuss more about the low resource topics privately, or hopefully we Google not. Maybe DataScience Singapore can have an extra session in the future related to this one. Thank you again for having me here.
Oh.
How about you?
Thanks, guys. Thanks for hosting. I really like talking to people, in case it wasn't clear. So please send me emails if you want to send me emails. LinkedIn is very annoying. Corentin@camus.ai. Or you can use contact if you can't spell my name. That also works. That goes to me and Al. All right. Thanks a lot.
All right. Oh.
Yeah. So Alam, do you have any parting words for our audience?
Oh yeah. For all of the audience, if you want to get more events like this, you can send us a message to DataScience Indonesia or DataScience SG, or even to the Google the developer space. And also for all of our audience from Indonesia, if you want to know more about DataScience Indonesia, you can go through to our website, datascience.id. We have the Telegram, we have the forum. We also have the free workshop every month to go to about data science, and also data talk like this every month. Yeah.
All right.
Thank
great.
you all.
Yeah. So yeah, for our DataScience SG, the community, basically those of you who are tuning in. Yeah, so we do have data science communities, from our neighboring countries. We have DataScience Indonesia, DataScience Malaysia. I think there was a commenter from DataScience Malaysia. We also have DataScience Bangkok, who is a close friend of ours. All right. So yeah, do follow all these other platforms, because there's more to gain, from learning from other countries about their problems. Right, Singapore, we just have 4 languages. Other countries, they have much more interesting problems when it comes to handling text. Right. So yeah, with that, all right. Again, thank you very much. All right, the panel speakers, thank you very much, Alam, All right, thank you very much for
you.
my backstage
Thank you.
crew. All right, my name is Rizal, and with that, all right, I'm gonna end the stream soon. Signing out.
Good
Bye.
night. See you. Bye.
Thank you. Thank you all.
Thank you. Thank you all.